Have you ever noticed how streetlights magically turn on when the sun goes down and switch off when the sun comes back up? It's not magic, it's smart technology. And at the heart of it is a device called a photocontrol, or sometimes a photocell. Today, we're going to peek behind the curtain of this everyday wonder, understand how it works, and even learn a little about what to do if the street light decides to stay on all day. Imagine a tiny special sensor inside that photocontrol. We'll call it the light detector cell. This cell is like a clever little resistor, kind of like the volume knob on an old radio. When you turn the knob, you change how much electricity can flow, making the music louder or softer. Well, this light detector cell does something similar, but it changes based on light. During the day, when lots of sunlight hits the cell, it's like turning the volume all the way up for electricity. The cell has very low resistance, meaning electricity can flow through it very easily. As darkness falls, less and less light hits the cell. Its resistance starts to increase. It's like turning the volume down for electricity. It becomes harder for the current to flow. Now, this light detector cell is connected to another part called a relay. Think of a relay as a tiny, clever switch operated by electricity. In broad daylight, with low resistance, enough electricity flows through the light detector cell to energize a small electromagnet inside the relay. This magnet pulls a tiny arm, we call it the armature, and holds it tight. When this arm is pulled in, it actually breaks the electrical connection to the streetlight's ballast. The ballast is like the streetlight's power brain. So, with no power, the lamp stays off during the day. As night falls, resistance increases. Less electricity flows, the electromagnet gets weaker and weaker. Eventually, it can't hold the tiny arm anymore. The arm snaps back into its original position. When it snaps back, it completes the electrical connection to the streetlight's ballast. Power flows to the ballast, and the streetlight begins its journey to turning on. Later, the sun rises again. The resistance decreases again. The whole process simply reverses. Light hits the cell, resistance drops, the electromagnet pulls the arm back, and the power to the lamp is cut. The light turns off. So, it's a clever dance between light, resistance, and a tiny electrical switch that makes those streetlights seem so smart. Now that we have a better understanding of how photocells work, let's talk about troubleshooting your photocell. A healthy photocontrol, as it's getting to turn on, will make a very soft, gentle humming noise as it's sensing the light change. Then, you'll hear a distinct, quiet click as the internal switch closes, sending power to the lamp. But what if something's wrong? If a photocontrol is defective or damaged, it might make a loud, growling or buzzing noise as it tries to turn on. This means its internal parts are misaligned or struggling. It might growl and never fully turn on, or it might growl and then finally click. Either way, if you hear a growling or buzzing photocontrol during testing, it's a sign it's faulty and should not be used. Think of it as a warning sign from the photocontrol itself. How to test the photocontrol? The easiest way to test one is to simply cover the photocell with your hand to simulate darkness. you should hear that gentle click as it tries to turn on. Then, uncover your hand, and you should hear another click as it tries to turn off. Do this a few times to see if it responds consistently. Now, for a trickier test, cover the cell completely and then very, very slowly uncover it in tiny stages. If you're really gentle, you might be able to trick the cell into making that soft, healthy hum just before it clicks. If, during this slow uncovering, you hear that growling or buzzing sound, replace it immediately. So what's the most common sign of a failed photo control? Well, it's a street sign that's burning night and day. We call this a day burner. This happens if that internal switch gets stuck on the on position, often because the parts have gotten too hot and actually welded together. Why does this happen? Sometimes, if the internal switch isn't making a good connection, it can chatter or rapidly open and close, causing heat buildup, which can eventually weld the contacts together. Another common culprit is excessive heat at the connection points where the photo control plugs into the light fixture. Over time, this heat can weaken the plastic and deform the contacts, leading to a poor connection. A poor connection causes electrical arcing, which generates even more heat, creating a vicious cycle that leads to early failure. Always inspect the receptacle. Whenever you're replacing a photocell or even just checking one, always inspect the part it plugs into for signs of heat damage. Look for discolored, charred, or melted plastic. If the receptacle itself is damaged, replace the entire light fixture. Otherwise, your new photo control will just fail quickly too. One final tip for installation. When you put a new photocell into its receptacle, make sure it locks firmly into place and doesn't pull out easily. Also, ensure that the mounting screws for the receptacle are fully tightened. If it's not seated properly, tiny vibrations can cause it to lift slightly, leading to those damaging electrical arcs and heat that cause premature failure. So, the next time you see a streetlight turn on, you'll know it's not just magic, but it's the precise work of a clever little photo control, helping us light up the night safely and efficiently. Thanks for listening.